video. In today's video I will show you how to use block store to persist your app signing across multiple devices in Android. Now this tutorial is only specific to Android because block store concept is only specific to Android. I'm not sure what is the iOS equivalent is. If you know, do let me know in the comments and I will make a video of it. What is block store? So in case you don't know, suppose I have an app and I have a sign in option in my app, and once the user is signed in, I am saving some token inside my app. Now where should I save these tokens? Preferably user store it in, like we developer store it in shared preferences or room database or preferences data store. Actually this is not correct. What Google recommends is you should save that token inside block store. Firstly, block store cannot store large amount of data, so don't make that mistake of storing large amount of data. Secondly, block store data is saved in Google Play services. It is not stored within your app, and you can encrypt that data as well as you can store it on cloud as well. So if in case I uninstall, some user uninstall my app, and tomorrow if he tries to reinstall it, or if he purchases a new device and on that new device he reinstalls my app, then I can automatically maintain my sign-in session because of that token which is present inside block store. So one thing which the user has to do is, like we can't really control it. He has to go to settings, then he will have to select Google, and inside Google he will have to select backup, and inside backup he will have to enter his email address and all that stuff, and enable backup option. Then only this block store thing will work correctly. So yeah, let's get started. If you are interested in knowing more, you can check out this documentation. So as usual, I have created a Flutter application. Okay. So here inside over here I have refactored my homepage widget, and I have created a method channel for this called block store platform. Next I have created few buttons. So first button is to store unencrypted data, second button will store encrypted data, third button is to read the unencrypted data which we have stored, fourth is to read encrypted data which we have stored, fifth is to delete one of the keys. Like here we are deleting the unencrypted data key, but you can delete the encrypted data key as well. And the fifth button is to delete all the data which is present inside block store. So I will just show you guys a demo first. So I will quickly run the application. So meanwhile that the application is running, so and at the last I'm just displaying the data once we have read it using our buttons, like both the unencrypted as well as the encrypted data. So here is our screen. So first I will store some unencrypted data. So here you can see that I'm sending this unencrypted data, okay, and for encrypted I'm just sending this data. So first I will click on save unencrypted data. The data is saved. Now I will click on save encrypted data. That is saved as well, and both have different keys. So in block store you store data in key value pairs. Next I will try read unencrypted data. So here you can see in the text it is printed super unencrypted secret data. Now I will read encrypted data. So it has read this as well. Now I will delete the unencrypted data key. Okay, now it has deleted. If I try to read unencrypted data again, it won't work. So here you can see the text is not changing, and if I want to delete all data, I can click on delete all data as well. Now all data has been removed. If I try to click on read unencrypted data, it won't work. Similarly for read encrypted data, it won't work. Now what I will do, I will save again the data which I already have, like save unencrypted data, save encrypted data. I will try to read it. Okay, I am able to get the unencrypted data, I am able to get the encrypted data as well. Now I will uninstall my application. App info, uninstall app. Okay, now I will try to run my app again, like I will try to reinstall my app. So this could happen on a new device or it could happen on a similar device as well. But even for new device the user has to enable backup. Okay, so now I won't save any data. I will directly read the data. So here I will see. So here you can see I am still able to read the data. Similar. So yeah, now let's check the implementation. So as usually on the Flutter side I have only created few buttons and I'm invoking the appropriate methods and sending the data as well. Similarly over here and here we are just invoking the appropriate method here as well for deleting unencrypted data and for deleting all data. Next, you have to open your Android folder inside Android Studio. You will have to go to build.gradle. Firstly, make sure you are using at least Kotlin version 1.8.20. Next, you will have to change the mean HDK version to at least 21. I have set it to 23. And here in dependencies, you will have to add this block store dependencies inside your build.gradle. Next, inside main activity, I am initializing our method channel result. So this will send data when we are trying to read from native side to Flutter side. And here we have initialized our block store client in on create method. Next, inside on configure Flutter engine, I am first defining our method channel of block store platform. Then once save unencrypted data is called, I have defined one key over here. So this is my package name followed by dot key one. You can give any key name, but make sure it is unique and you use the same key while reading the data as well. And here I am getting the data which we are sending it from Flutter side, converting it to a byte array. Then we need to create a store request, and we have to set the byte, set the key, and then build it. And then we need to pass it to our client dot store bytes, and you will get a success listener as well as a failure listener. So here I'm just logging it to the console. If you want to send it back to Flutter side, you can do that as well. I will show you how to send data to Flutter side as well. This is for save and encrypted data. It is similar. I've just changed the key. I'm getting data from Flutter side. Here I'm setting our bytes as well as setting our keys. Now to store the encrypted data, first you have to add this check: is end-to-end encryption available or not? And end-to-end encryption is available only from, I think, Android 8 or Android 9. And also the user has to set a password, a pin or biometrics on his mobile phone. So if you are curious, you can check the documentation for more like I think they must have specified Android. Yeah, so here you can see it is available from Android 9 or higher, and user must have set a screen lock. Okay, if he has not, then you can just fall back inside on failure listener and save the data in unencrypted format. Okay, and here this data of encrypted data I'm backing up to the cloud as well. So once the data is encrypted, even Google server can read it. Again, this data is stored on Google server, like on Google Play service outside your app. And here I'm using dot store bytes. Then I'm just sending our builder, and once it is successfully saved, I'm logging it to the console. Similarly, for reading unencrypted data, you have to pass the same key. And here I am passing, if you want to read a list of keys, you can pass a list of keys as well. And here we are building a retrieve request, sending it to our client. And here it gets our block store data map, and we are looping over it. And I'm just comparing if key is equal to key 1, then send the data to Flutter side. So this is how you send the data to Flutter side using method channel result dot success. Okay, and if you want to send all data, you don't have to add this kind of if check as well. Okay, this is for failure. Similarly, for read encrypted as well, same thing I'm doing, like unencrypted. Not much difference. The unencryption part is taken care by Blockstore itself. We don't have to worry about that. So I'm just sending data back to Flutter side. And for deleting the data, we can specify a key, then generate a retrieve request, and then call delete bytes. And for deleting all the data, just call delete all requests, set delete all dot build, and here we can delete all bytes. Okay, so yeah, that's it. Thank you for watching. Bye.